everybody, here is example from 7.3 and it deals with real-world graphs. So like pictures, graphs communicate a lot of information. So you need to be able to interpret, draw, and communicate about graphs. In previous chapters, you learned to use bar graphs, histograms, and box plots. Then you learned to graph data from recursive routines and equations. Most graphs you've seen represent functions. Some of these graphs were lines or linear, and others were curves or nonlinear. In this investigation, in this lesson, you will learn vocabulary for describing graphs, like linear and nonlinear, and you'll interpret graphs for some real-world situations. Excuse me. So, let's look at this example A. This graph shows the depth of water in a leaky swimming pool. Tell what quantities are varying and how they are related. Give possible real-world events in your explanation. Okay, so what I see is in this graph, I see time. I see time and I see depth. All right, so those are the two variables. So those are the things that are going to be varying. Time is going to be increasing, and the depth of the water seems to be decreasing and then increasing and then decreasing again. All right, so let's start to talk about some quantities that we see. So first of all, I see that from 0 to looks like 16 hours. So there is 16 hours that we've tracked the depth of the pool. Okay, so that's something that I've noticed. Also, I noticed at t equals 0, so at t equals 0, the depth is 2, so we can say d equals 2. All right, so then from there, I see it's decreasing. It's decreasing for about the first 6 hours, right? Excuse me, so it's decreasing for 6 hours. One reason why that might be because it says give possible real-world events in your explanation. Someone just was swimming in the pool. They may have been splashing some stuff out. They might have been playing in it, whatever. So it's decreasing for the first 6 hours. So we know it's decreasing for the first 6 hours. And then it increases for the next 4 hours until t equals 10. So we can say then increases for 4 hours until t equals 10. Now what we can do is we can say it increased from, well, at 6 it was at 1, and at 10 it's up to 3. So we can say not only did the hours increase, but we can also say the depth increased. And we can say it increased for 4 hours from 4 hours until t equals 10. And we can say from a depth of 1 foot to 3 feet. So not only do we have to talk about time, but we can also talk about what the depth was. All right, and then from 10 until 16, it seems to be decreasing slowly, and then decreases slowly for the last 6 hours. All right, so we've said where it starts, decreases for 6 hours. Where it ends at 6 hours, right, we said from 1 foot to 3 feet. It goes to 3 feet for how long, and then it says, where do we kind of end up at the end here? It looks like, and it ends at, let's say, about 2.5 feet. We're not real exact here. We're just kind of guessing. It looks like it's about 2.5. Okay, so we can talk about at what happens at this time, this time, this time, this time, and then also what is the depth at those spots, and what happens in between. All right, so there's a good example A on real-world graphs.